Okay, so again, we're going to continue talking about graphing quadratic functions, and these functions are going to be in standard form, so our vertex form. So it looks something like this: f of x equal a times x minus h squared plus k, where the vertex is hk, and remember, if a is positive, the parabola opens up. If a is negative, the parabola opens down. Okay, so let's look at this example. All right, number one. So it'll be the same parts as the previous one. So it'll be parts A, B, C, and so on. Okay, so let's suppose we had, let's say f of x equal 2 times x plus 2 squared minus 1. Alright, so f of x equal 2 times x plus 2 squared minus 1. Okay, first of all, let's determine if the parabola opens up or down. So if you look at A, remember this is vertex form or standard form. So if you look at this, and if you look at A is 2. Since A is positive, the parabola is going to open up. So at point A, the parabola opens up. Okay, since A equals 2, which is positive. Alright, part B, you're going to find the vertex. So the vertex, remember, has got to be x minus h. Alright, so remember, in this case, you're going to say f of x, in your mind, you're going to say f of x equals 2 times x minus the negative 2 squared, and then minus 1. So this is your h, and this is your k. Alright, so the vertex is negative 2, comma, negative 1. Okay, negative 2, negative 1. Okay, C, remember, a function is always going to have a y-intercept. So we have, well, a quadratic function is always going to have a y-intercept. So if we have y equals the y-intercept, so we're going to let x equal 0. And so wherever we see the function, wherever we see the variable x, I plug in 0. So I get y equals 2 times 0 plus 2 squared minus 1. That's 2 times 2 squared minus 1, because 0 plus 2 is 2. 2 squared is 4. 4 times 2 is 8. And then 8 minus 1 is 7. So my y-intercept is 0, 7. Now, for the x-intercept, let's think about this. Let's first of all visualize where the vertex is. Now, that's all assuming you wrote the vertex correct. Okay? So it could have been wrong here. So you may want to still do this setting this y equal to 0 and then solving for x, because you could have made a mistake here. You could have said 2 negative 1 instead of negative 2 negative 1. But the vertex is negative 2 negative 1, so I want you to think about this. So if the vertex is negative 2 negative 1, here's the vertex somewhere around here. Alright? Now the parabola opens up, so you do see that there are going to be x-intercepts. Okay? Alright, so let's find them. So there are x-intercepts, so let's find the x-intercepts. Now to find the x-intercepts, you're going to let y equals 0 or f of x equals 0. So here's your y. So you're going to take this function, you're going to set it equal to 0. So you get 2 times x plus 2 squared minus 1 equals 0. Alright, and then you got to get the square, the binomial square by itself before you take the square root. Remember, you have to use the square root property. That's the idea here. So we're going to add 1 to both sides. So add 1 to both sides. Combine like terms, we get 2 times x plus 2 squared equals a 1. Then divide both sides by 2. And then the 2's divide out. So you get x plus 2 squared equal, and then 1/2. So let's say 1/2 is, let's write as a fraction, so 0.5. Then I'm going to take the square root of both sides, just like this. So the square and square root into each other, so you get x plus 2 equals plus or minus the square root of 0.5. Right, just like in the previous lesson, you're going to split this up. So you can say x plus 2 equal the square root of 0.5, and then x plus 2 equals negative square root of 0.5. And then subtract 2, so you get x equals negative 2 plus the square root of 0.5, and then subtract 2, you get x equal negative 2 minus the square root of 0.5. And then use your calculator to approximate these x-intercepts. These are your x-intercepts. So use your calculator to approximate this. So if using your calculator correctly, this is what you should get for this one. So let's see. Alright, 2 is negative. You should get negative, approximately equal to negative 1.3. So that's your one of your x-intercepts over here. Let's see what we get. Let me do this again. So 0.5 square root, it's negative, plus negative 2. You should get 1.3. All right. So your x-intercepts are approximately equal to negative 1.3 and a positive 1.3. Okay. All right. So then the other thing you got to do is find the axis of symmetry. All right. So the next thing you do is find the axis of symmetry. So the axis of symmetry. All right. So the axis of symmetry. Remember, the axis of symmetry is a vertical line. You name a vertical line x equal, using the equation x equal a number. Now you know your vertex. So your vertex is negative 2, negative 1. So your axis of symmetry is the x coordinate of that vertex. So it's x equal negative 2. All right, and then you want to graph. And then the next thing after you graph is you want to determine the domain and range. Okay? And then next thing you want to do is you want to ask yourself, is or does f of x have a maximum or a minimum point? Maximum or minimum point. All right, and then the next one would be you would say the maximum, or what is the maximum or minimum value. Okay, all right, so let's go ahead and graph this and see what happens. So I have that my vertex is negative 2, negative 1. So that's right here, negative 2, negative 1. And that my y-intercept is 7, so that's here. And my x-intercepts are negative 1.3. All right, let me make sure, let me go back here. All right, because I'm looking at my my graph, and I'm noticing that my x-intercepts, oh, this is supposed to be, I'm sorry, I messed this up right here. Right here? Okay, so let's do this again. So 0.5 square root negative plus 2 negative equals, okay, so this was an error right here. So that should be negative 2.7. And when I realized it was an issue because 1.3 would have been here, and then the graph, there's no way the graph would have crossed that other x-intercept. So my x-intercept is incorrect, so make sure y'all fix this. This should be negative 2.7, this should be negative 1.3. Okay, so my x-intercepts are negative 1.3, so that's about here. And my other one is about negative 2.7, that's about here. Okay, and then I'm going to draw my axis of symmetry to help me with this graph. So my axis of symmetry is here. And the axis of symmetry goes through the vertex. And then I know that at this point here, this y-intercept is 2 units to the right of the axis symmetry. So I'm going to go 2 units to the left of the axis symmetry to find the other points. So remember, these quadratic functions are symmetrical about the axis symmetry. And then all you do is just draw your graph and you're done. That's all you do. Something like this. Just do the best you can with drawing it. Make sure it looks like a parabola so you don't lose any points. And that's it. There's your graph. Now, we go back and answer the remaining part of the question. So, let's see. The remaining part of the question is... Alright. So we'll find the remaining range. Well, remember, the domain of a quadratic function, all quadratic functions, whether it's pointing up or pointing down, remember, is going to be from negative infinity all the way to infinity. Alright, so that's the domain. So from negative infinity to infinity. The range, remember, you go from bottom up along the y-axis. So I start touching a graph when I'm at this minimum point. So that's the minimum point. And so that y-coordinate is a -1. So we go from -1 all the way to infinity. These arrows, that stop, it just keeps on going. So my range is going to be bracket -1 to infinity. Now, does it have a maximum minimum point? Well, we just discussed it. It does have a minimum point, so the answer is minimum. Okay, minimum point. And the question is, what is the maximum value, minimum value? So the minimum value is going to be the y value. Okay, so it's -1. So the minimum value, so the answer, the minimum value is -1. Okay, so that was number 1. Okay, let's look at number 2. All right, number 2. Okay, let's suppose we had this. All right, number 2, let's suppose we had f of x equal negative x minus 2 squared plus 1. So you have something that looks like this. All right, now, so this is in standard form, keep that in mind. So in part A, so the question is, if you look at A, so remember, this is A times x minus h squared plus k. All right. So if you look at A is negative. So remember what that means. So since A is negative, since A is less than 0, the parabola opens down this time. Okay, it opens down. Okay, part B, the vertex. So the vertex is going to be x minus h, so h is 2 and k is 1. So 2, 1. Okay. C, the y-intercept. All quadratic functions are going to have a y-intercept. So notice that when you draw a parabola, it's always going to cross the y-axis. So the y-intercept, you're going to let x equal 0, and to see what happens. So when x is 0, I get y equals -1. So if you want to write this -1, you can. So -1 times x is 0, say. So 0 minus 2 squared plus 1. 0 minus 2 is a -2, so we get -1 times a -2 squared plus 1. -2 squared is a +4. A +4 times a -1 is a -4. A -4 plus 1 is a -3. So my y-intercept is 0, -3. Okay. D, I want you to think about this. This vertex is in the first quadrant. It is going down, so there are going to be X-intercepts. So let's find them. So the X-intercepts, you're going to let y equals 0 this time. So what you can do is you're going to set this function equal to 0. You let y equals 0. So I get -1 times x minus 2 squared plus 1 equals 0. Now you got to be careful with this. So the others were not that bad to solve for x, but look at the steps that you have to go through for this one. First of all, you got to get the binomial squared by itself, just like in all the others. Okay, so I'm going to subtract 1 from both sides. Then you combine like terms. I get -1. You may want to put this as -1 if you have to. -1 times x minus 2 squared equals a -1. Now remember, don't distribute this because you cannot distribute this because you can only distribute this if this exponent here is a 1. So remember the order of operations. Before you distribute, you would have had to square this binomial and then distribute. But that's not what you want to do. What you want to do is at some point use a square root property. But before you do that, you gotta have this to be a positive 1. So what you can do is, let me go ahead and rewrite this over. You can divide both sides by negative 1. And so negative 1 divided by negative 1 is a 1. 1 times this is x minus 2 squared. Equal, and then negative 1 divided by negative 1 is a positive 1. And now you take the square root of both sides, plus or minus. And so the square and the square root into each other. You get x minus 2 equals plus or minus 1. And you don't need your calculator for this because there's no approximation because this is a real number. I'm sorry, this is an integer. So we get x minus 2 equals 1. X minus 2 equals a negative 1. Add 2 to both sides. One of my x-intercepts is 3. Add 2 to both sides. The other x-intercept is a 1. Okay? So my x-intercepts are 3, 0, 1, 0. Alright, E is where you write your axis of symmetry. Alright, so remember your axis of symmetry, you're going to use the vertex, and my vertex is 2, 1. And so the axis of symmetry is a vertical line, and it's a vertical line that goes through this vertex. So it crosses the x-axis at 2. So you can say x equal 2. That's your axis of symmetry. We're going to graph. Alright, so and then once we graph, we're going to find the domain and range. And then we're going to determine if this has a maximum and a point. So we're going to use that maximum point for h. Okay, so let's just graph this. And so when I graph it, I'm going to graph the vertex. So the vertex is at 2, 1, so that's here. And then my parabola is opening down, and so it's going to cross the y-axis at negative 3, so right here. And the x-intercepts are 3 and 1, so here's 1, here's 3. And draw your axis of symmetry. Draw the axis of symmetry, just like this. And then just see how you had this y-intercept? Use the distance here to find the other point on the other side. So this is 2 units. This has to be 2 units. So here's the point on the graph as well. And then all you do is connect them like this. Do the best you can. Just like this. Make it look symmetrical. Draw your arrows. And then that will be the graph. Now let's answer the question. So remember though, domain for all quadratic functions, all parabolas, domain is going to be all real numbers. So I can quickly just do this. Now the range though, you're going from bottom up. Now notice this time that the arrows are pointing down. So your range is going to be from negative infinity all the way, and then you're going to stop at this point. And so that point here has y-coordinate of a 1. So that's y-coordinate 1. So your range is going to be from negative infinity all the way to this y value, which is 1. So don't forget parentheses, though, around for negative infinity. So negative infinity to 1 with a bracket. All right, and then h, this is where you say f of x has a maximum point. So it is a maximum point. And then the maximum value is 1. So that number here has to match this number here. Okay? All right, so that was number 2. All right, number 3. All right, number 3. Suppose you had, let's see. Okay, suppose we had this one. F of x equal negative 1/2 times x minus 4 squared plus 3. Now that one's a little bit more challenging. This will be a little bit more challenging. All right, so we know that that f of x. Now remember, a here is negative, so you see a is negative. So f of x, or the parabola, will open down. The parabola will open down since a equals negative 1/2 is negative. Okay. Part B is where you find the vertex. So the vertex is, remember, it's x minus h. So h here is 4, comma 3. 4, 3. All right, C, let's find the y-intercept. So to find the y-intercept, you let x equal 0. So remember, a quadratic function is always going to have a y-intercept. So let's find it. So that's where you're going to let x equal 0. So we get y equals negative 1/2 times 0 minus 4 squared plus 3. 0 minus 4 is a negative 4, just like this. Negative 4 squared is 16, just like that. 16 times a negative 1/2 is a negative 8. Negative 8 plus 3 is a negative 5. So the y-intercept is negative 5. So 0, negative 5. Okay, D, do we have any x-intercepts? Well, let's think about it. So my vertex is in the first quadrant. So let's say it's here. It is opening down. The parabola is opening down. So yes, I will have x-intercepts. So I do have x-intercepts. All right, so let's find them. Now, this is a little challenging part, but just not that difficult. You just got to remember a couple of things. So remember, to find the x-intercept, you can let y equals 0. All right, so when I let y equals 0, so this right here, so I'm going to get this is equal to 0. So I'm going to say negative 1/2 times x minus 4 squared plus 3 equal 0. Okay. Now remember the whole idea. Just look at the previous number 2 that we just did. You got to get this binomial squared by itself. So I'm going to get rid of this 3 first. I'm going to subtract 3 from both sides, just like that. And I get negative 1/2 times x minus 4 squared equal a negative 3. Okay. Then what I would do next is this. I would go ahead, see how I have a fraction here? I would just do it in steps. I would just go ahead and clear this denominator. So I'll multiply both sides by 2. Watch, just like this. Times 2 times 2, just like that. Then these 2's divide out, and you have this right here is a negative 1. So you have negative 1 times x minus 4 squared equals a negative 6. That's what you have. Then, just like the previous problem, remember you have that negative 1? So then you divide both sides by negative 1. Negative 1 divided by negative 1 is 1. 1 times x minus 4 squared is x minus 4 squared, equal a positive 6 this time. All right? And now you take the square root of both sides, just like this, plus or minus. The square and the square root undo each other. You get x minus 4 equals plus or minus the square root of 6. Now, remember, you're finding the x-intercept, so now you have to approximate this. You see how this is going to be an irrational number, a square root of 6? So what I would do is just break into two parts like this. X minus 4 equals the square root of 6. X minus 4 equals negative square root of 6. Then add 4 to both sides, both cases, just like this. And you get x equals 4 plus the square root of 6. X equal 4 minus the square root of 6. And now just approximate. So I'm going to approximate here. Okay? So use your calculator and approximate what this is. So it looks like that one's going to be, let's see, 6 square root plus 4. So it's like 6.5. Okay, about 6.5. Over here, 6 square root. It is negative, though. I'm going to add 4. And you get positive 1.6. Okay, so 6.5, positive 1.6. All right. Then E is where you determine the axis of symmetry. E, so the axis of symmetry. So remember, the vertex is 4, 3. So the axis of symmetry is going to be where the graph crosses the x-axis, which is at 4. So it'll be x equal 4. We're going to graph. So I'm going to graph what we have so far. So when I graph this, I'm going to graph the vertex, which is at 4, 3. So that's about here. The Y-intercept is -5, so that's way down here, right here, -5. The X-intercepts, you have 1.6, about 1.6, and 6.5. So 1.6, let's say, is about here. 6.5, let's say, is about here. So I'm going to draw the axis symmetry now. Draw your axis symmetry, just like this. And then you just take this y-intercept and put the other point. So that is, look, if you look at it, that's 1, 2, 3, 4. So that's 4 units from the axis of symmetry, and then you go 4 units this way. 1, 2, 3, 4. And then you just connect them, just like this. And that's all you do. There's your graph. Just do the best you can with making it symmetric. Just make sure it looks symmetric, though. Okay? If it doesn't look symmetric, erase it, and then go back and see if maybe you made an error somewhere around here. Okay, but it should look like this. It should look symmetrical. Make sure it looks symmetrical. Okay, now don't forget about the arrows right here. Okay, so let's talk about domain and range. So G, the domain, remember the domain of a quadratic function is all real numbers, whether it goes up or down. It's going to be from -infinity to infinity. So remember, as it goes from -infinity, so let's say this right here is -infinity, it's going towards -infinity. See how this arrow is going down here? So I get a point on the graph. So I keep getting a point on the graph, on the graph, on the graph, and so on. Okay? So I'm going from -infinity to infinity. The range, okay, so for the range, see how the arrows are pointing down? So you're going from -infinity all the way to this maximum y value. Remember, the range is a set of y coordinates. You're going this maximum y value, and this maximum y value is 3. Okay, 3. So you're going from -infinity to 3 with a bracket. So remember, infinity, -infinity, you always use parentheses. For the numbers here, for the domain and range of a quadratic function, you use a bracket. All right, so we just discussed that this is a maximum point right here, so it's going to have a maximum point. So f of x has a maximum point. Okay, and the maximum value is, and so the maximum value, so the maximum y value is 3. And that number here has to match this number here. So it's 3. Okay, so that was number 3. Okay, let's do one more with this. And let's do this. All right, number 4. Okay, so number 4. You have f of x equal, let's say we had x plus 2 squared plus 4, let's say. Okay, x plus 2 squared plus 4. Let's actually make it negative. Let's do negative, and let's make this negative also. Okay, just change it. Okay, so part A, we know that since A is negative right here, -1, the problem is going to open down. So since A is -1, which is negative, the parabola opens down. Okay, part B, the vertex. All right, so just be a little bit careful. Remember, this is what we had. So I'm going to go ahead and just write the function over right here. So we had this as our function. That's a 2. All right, so that's x plus 2 squared minus 4. So you may want to rewrite this. Remember, this is going to be x minus a -2. Okay, so this right here is your h. And this right here is your k. So the vertex is -2, -4. All right. See, all quadratic functions will have a y-intercept, so let's find it. So to find the y-intercept, you can let x equal 0. So I'm going to get -1. If you need to put this as -1 right here. -1 times 0 plus 2 squared minus 4. 0 plus 2 is 2, so I get -1 times 2 squared minus 4. This is 4. 4 times -1 is a -4. So a -4 and another -4 is a -8. So my y-intercept is 0, -8. That's your y-intercept. Now, for the x-intercept, we're going to let y equal 0. But even before we start that, let's double check to make sure we have one. So my vertex is -2, -4. So -2, -4 is in the third quadrant. The parabola opens down, so it does this. So the question is, does the graph cross the x-axis? The graph does not cross the x-axis. So there are no, does not cross x-axis. So there are no x-intercepts. No x-intercept. So basically, if you know this is correct, so if you were very careful and this is correct, so you get this, you can do this, and then you're done. There are no x-intercepts. Okay, but let's suppose that you didn't think about this. So remember, what you do is you got to let y equal 0. So you got to take this right here, this function set equal to 0. So we have this. So we have -1. Put this -1. -1 times x plus 2 squared minus 4 equals 0. And just like the previous problem, we got to get the square part by itself. So I got to add 4 to both sides, just like this. And then combine like terms, I got -1 times x plus 2 squared equals a positive 4. Now you got to get rid of this -1 though, because before you take the square of both sides, this has to be a positive 1. So we divide both sides by -1. -1 divided by -1 is 1. 1 times this is x plus 2 squared equal. Now that 4 divided by -1 is a -4. Now I want you to notice what happens in the next step. When I do the next step, when I take the square root of both sides, and I on this side I get x plus 2, what you notice on this side is that you're taking the square root of a negative number. Well, the square root of a negative number is an imaginary number. So it's not a real number. So what that means is that there are no x-intercepts. So when you get to that point, you stop. There aren't any x-intercepts to be found. Okay? But again, all you had to do, assuming you did this correct now, is do this. Notice it doesn't cross the x-axis and you're done. But algebraically, this is what's happening. You're taking the square root of a negative number, which is not a real number. And so there are no x-intercepts. Okay, so the E part is where you find the vertex. So let's find the vertex. I'm sorry, the axis symmetry. Okay, the axis symmetry. And so the axis symmetry is going to be x equal the x coordinate of your vertex. So that'll be -2. So x equals -2. And then we're going to graph. So let's graph this. So when I graph it, I get, let's see, when I graph it, okay, so the vertex is at -2, -4, so that's here. Okay, the y-intercept is a -8, so that's here. And that's all the points I have. I don't have any other points. So what that means, remember we did this in a previous lesson. There was one like this in a previous lesson. So there are no x-intercepts. I can't use the x-intercepts to help me graph this. So I'm going to go ahead, though, and graph the axis symmetry. I'll go ahead and do that. Just like this. And I'm going to use the fact that since, remember, the quadratic function always has a y-intercept, so I found it. 2 units to the right of the axis symmetry, so I'm going to go 2 units to the left. And let's just do one more point. Let's suppose x is -1. So we'll use a t-table. If x is -1, let's see what we get. So we're going to go, I'm going to rewrite the function right here. So y equals -1 times x plus 2 squared minus 4. So I'm saying x is -1. So I get -1 times -1 plus 2 squared minus 4. -1 plus 2 is 1. So I get -1 times 1 squared minus 4. 1 squared is 1. 1 times -1 is -1. -1 minus 4 is a negative 5. So when x is negative 1, I get negative 5. So negative 1, negative 5 is here. So once I find this one, I found this one because they're symmetrical, and then you can just connect them. So you have so what you want to do is always try to get at least 1, 2, 3, 4, 5 points in your graph. So you see those 5 points? 1, 2, 3, 4, 5. So we have 5 points in your graph. Okay? And now the domain, remember the domain of a quadratic function is all real numbers. So as you go on the x-axis from left to right, you're going to get a point in the graph. So it's from negative infinity to infinity. So that's your domain. So your domain is negative infinity to infinity. Your range, though, depends on where your vertex is and whether it goes up or down. So your vertex is a maximum. It is pointing down. So your range would be from negative infinity all the way to this maximum y value. And this maximum y value is a negative 4. All right, so negative 4. So from negative infinity to a negative 4 with a bracket. So remember, your range is a set of y coordinates. So that's why you choose a negative 4. Don't choose the x coordinate. It's the y coordinate because you're dealing with range. All right, and then we already talked about this. Your function has a maximum value. So f of x has a maximum value, has a maximum point rather. And the maximum value is whatever that maximum y coordinate is. So this largest y coordinate you see is a negative 4. And that should match this. All right, and so that's the end of this part. Okay, so go back and review this. So there are quite a few problems on graphing using a quadratic function that's in standard form. So go ahead and review all this again. Notice all the little parts you have to deal with.